there are a few valves and switches that are used in these systems that contribute to the overall function of the components that we're operating. We need to maintain proper brake balance. There are some behaviors of the equipment in the system that require some regulating when it comes to how they operate and operating under hydraulic pressure. So any part of the system isn't carrying more load than it's supposed to. I want to take it back to wheel cylinders. And the seals inside of the wheel cylinders, the cup seals, have a cup expander inside of it. So these cup expanders have a spring in the middle of them, and the taper on them fits the inside profile of the cup seal on the wheel cylinder. Now remember the purpose behind this. When this is sitting at a resting position, there's a little bit of tension on this spring, which means that cup expander is putting a little bit of pressure on the inside of that cup. Before the cup expanders were introduced into wheel cylinders, there was only the cup seal and the piston. Inside the wheel cylinder, in order to keep the cup seals from allowing fluid to bypass out or to allow air coming in, like the way they function on master cylinders, you can have fluid flowing over and bypassing over if it's coming from the face side of a cup seal. Before cup expanders were aiding in sealing those at a resting position, the purpose of the residual pressure check valve was to keep a slight amount of pressure to the wheel cylinders to help keep the cups expanded against the bore of the wheel cylinder. Eventually, those were replaced by installing a little mechanical piece like this spring with the cup expanders. The residual pressure check valve was normally located on the outlet port of the master cylinder that would be going to the rear brakes. This would allow the system to keep hydraulic pressure on the cup seals to prevent them from leaking when the vehicle is parked for any period of time. With the addition of the cup expanders, that ruled out the need for putting extra valving and development into the master cylinder design. So a spring with two tapers on the end of it that fit in between the two cup seals and the wheel cylinder was a much more economical choice and a better design in the long run. So that is how cup seals are prevented from leaking fluid and allowing air to come in by keeping that seat nice and tight against the inside of the wheel cylinder. So residual pressure check valves are going to be found on older vehicles with drum brakes. As drum brakes are phased out over time with newer vehicles, they're becoming less and less common to see. This is a combination valve, named so because it combines several different functions of different valve assemblies into one part. The part that I'm going to talk about first is this electronic terminal right here. This is part of the pressure differential switch. Our circuit is split into two halves, and in between those two halves we have a pressure differential switch. If one of those hydraulic circuits were to develop a leak, or there was uneven pressure for one reason or another, this little piece in the middle here would shift to one side or the other. So this section right here, if there was more pressure on this side than this side, a difference in pressure, the differential pressure switch would move to the side that has the least amount of resistance, so towards the low pressure side. As it does this, this middle portion here would move over, and this electrical contact would contact the larger radius on either side. So as the pressure differential switch moves one way or the other, it's going to close an electric contact, and that is going to illuminate the red brake warning light. The red brake warning light is illuminated on the dashboard, and it's red for a reason. If an engine does not have oil pressure, the engine oil pressure light will illuminate and it's red. That means shut the engine off, pull over, do not drive the vehicle. If we have yellow lights or amber lights, they're more of a cautionary warning to address whatever system is being affected. The red brake warning light is a light that can illuminate from a number of different reasons. One being the pressure differential switch, if it moves over and completes that electrical circuit, indicating a loss of pressure on one side of the circuit. Another way is with a fluid level switch. This is going to be located in the master cylinder reservoir, and it has a float. There are a couple of different designs. This one actually has two wires coming off of it to a connector, and when this float is raised off of its contacts, the light will not illuminate. As fluid level drops and drops down to the minimum, this will sink down, this will ride farther down on the shaft and engage two electrical contacts and illuminate the red brake warning light. On some brake systems, the fluid level sensor is contained within the master cylinder fluid reservoir and does not touch anything. Down below it, there may be a reed switch, which is a very thin, flexible piece of metal that's going to close an electrical contact. And when the float inside the reservoir gets close to it, there will be a magnet on the bottom of that will help pull that reed switch into contact, also illuminating the red brake warning light, indicating that the fluid is low. On more advanced vehicles with more complex driver warning systems, there may actually be a light or a message display that specifies that the fluid level in the master cylinder is low. The bare minimum requirement is that it must illuminate a red brake warning light if our system is not safe. So no fluid or too low of fluid in the master cylinder is an indication that our system is not a safe operating system. So what else can illuminate the red brake warning light? Low fluid level, loss of pressure on one side of the circuit, pressure differential switch. It can illuminate when the parking brake is raised off of its resting position. So if the parking brake is applied, whether it's a foot pedal style or a hand lever pull style, if that parking lever is engaged, that will also turn on the red brake warning light. When we have a vehicle that's equipped with front disc brakes and rear drum brakes, there are a couple valves that need to be used in the system in order to create an equal brake balance for proper operation of the brakes. Drum brakes have the ability to provide more stopping force for pressure given to them compared to disc brakes. So when we're operating with drum brakes on one part of the vehicle and disc brakes on another part of the vehicle, as the driver depresses the brake pedal and the pressure is routed to the front disc brakes and the rear drum brakes, as that pressure increases with the driver input force, the amount of stopping force that is generated in the drum brakes is going to be higher than the disc brakes. So if that pressure was not regulated somehow, what would happen is the rear brakes would lock up as the pressure increases on the system for a gradual stop. Meanwhile, the front brakes are operating normally. That pressure is forcing the friction material to clamp around the rotor. If the rear wheels lock up, it becomes a safety hazard. Once the tires lose traction, there's no directional stability, and the vehicle can go into a spin or go out of control. So in order to maintain a safe level of stopping pressure to the rear brakes, we have to limit that pressure. And that's going to be in proportion to the pressure going to the front. This introduces the proportioning valve. Proportioning valves can be in line, like this. They can also be mounted to the master cylinder outlet ports that go to the rear brakes. This would be an example of something that is a diagonal split front wheel drive vehicle where we have 4 ports coming off of the master cylinder. There is a pressure differential switch right here inside the master cylinder. So this is taking that combination valve and building it into the design of the master cylinder. In the proportioning valve, we have some springs that are calibrated to a certain resistance, and it's going to limit the amount of pressure going to the rear brakes as we increase pressure. The point at which the pressure is limited to the rear brakes is called the split point. This graph is a representation of the proportioning valve and how it limits pressure to the rear brakes. For initial stopping, there is equal pressure going to the front brakes and to the rear brakes. Now at some point, wherever the calibration is inside that proportioning valve is going to reach the split point. It's going to overcome the spring pressure for the calibrated spring that's in there, and it's going to limit that pressure going to the rear brakes while we still maintain equal input to output pressure on our front brake hydraulic system. In this example, our split point occurs somewhere around 200 psi, and then we have a rise of 100 psi and a run of 200 psi. This line is 1-to-1, and the slope of the proportioning valve pressure is 100 over 200, or 1 over 2, or equal to 1/2. It will still increase as more force is applied to the brake pedal from the driver's input, but it's going to maintain about half the pressure compared to what's going to the front brake. So that's our proportioning valve working towards limiting pressure on the rear drum brakes. When this spring is overcome by hydraulic pressure, it's going to reach the split point. At the split point, the valve piston is going to close inside of here, and it's going to block off additional fluid coming from the master cylinder. But that piston will still be able to move and increase the amount of pressure going out to the rear drum brakes. Another type of proportioning valve that's not directly associated with drum brakes operates in a different manner. A load sensing proportioning valve, or a height sensing proportioning valve, will change the amount of pressure routed to the rear brakes as the vehicle is loaded heavier in the rear compared to empty, and that has to do with how far that chassis is going to sag with weight added to the rear of the vehicle. So this is going to be something you might find on an SUV, pickup truck, van chassis, something like that, that can be empty and considerably lighter than when it is filled to maximum capacity for the gross vehicle weight rating. This is an example of how that can be mechanically connected. This unit right here is our proportioning valve assembly. This is the height sensing proportioning valve. And it is connected to a linkage rod, and that linkage rod is connected to the axle. As the chassis is loaded heavier, this rod in relation to the valve here will be sitting at a different angle of position. Inside this valve assembly, it's going to limit the amount of pressure going to the rear brakes when we're fully empty, so when the chassis is higher. So with our linkage rod at a steeper angle, it's going to allow less pressure to go through this to the rear brakes. And then as the vehicle is loaded heavier and heavier, this is going to rest farther and farther down, and that is going to increase pressure to the rear brakes. If we had full pressure to the rear brakes at all times, then we might have a lockup and loss of control of the vehicle. On one end of this linkage rod, it may need to be adjusted. So there's a threaded adjustment here with the jam nut. On this example, there's a bleeder screw here. So whatever vehicle this is from, I'm guessing it's a Toyota. Whatever vehicle this is from, there is likely a point in the bleeding procedure where this valve has to be bled in sequence with the other valves and the other bleeders in the system. The specifications for each vehicle may be different for the pressure that's supposed to be present at each wheel. When we're testing components for possible restrictions, or if they are regulating the pressure correctly, we may need to compare it with a set of pressure gauges. You may need to use a brake pressure test kit. This kit has several different adapters and 2 gauges. And depending on the fittings for your vehicle, you will have to select and choose from these in the kit and then adapt them to your system. And before you can read an accurate pressure, the air needs to be bled from the system in order for the gauges to read correctly. If we have an air pocket in the gauge, that will translate to inaccurate data. So the gauge actually has a bleeder on it. It's not likely that you will have to use a tool like this very often. Most technicians will opt for the method of testing that's going to use the least amount of time. So if you get to a point where you need to test with this kit, it's to narrow down on a hard to find problem, or if you suspect something is wrong that you cannot easily determine without testing the pressure is when you'll need to use it. Metering valves are another valve that's used when a vehicle has front disc brakes and rear drum brakes. The metering valve has to do with our drum brake assembly and the springs that are pulling these shoes back to the inside of the drum, back to the inside of the assembly and away from the surface that the friction material is riding against when the brakes are applied. The metering valve delays application of the front brakes until the fluid pressure entering the wheel cylinder can overcome the mechanical force against those springs that are trying to pull it back together. The proportioning valve is used to limit the amount of pressure going to the rear brakes so the stopping force is equal in the rear as it is to the front. And the metering valve delays the operation of the front brakes until we overcome the spring pressure on the drum brakes. So the saying that we go by is we meter the front, proportion the rear. Meter the front, proportion the rear. So the metering valve delays operation of the front brakes until we overcome spring pressure at the drums, and the proportioning valve limits the amount of pressure at the split point to provide even brake balance from front to rear. The internal design of the metering valve has a weak spring and a strong spring. The weak spring is going to allow a pintle inside to remain open when there is 0 pressure on the system. Without any pressure on the system and that pintle held in an open position and that passes through the inside of the main piston, that allows for fluid expansion and contraction so that the system isn't locked and self-applies the brakes. It allows venting of the fluid at the master cylinder and that fluid to expand and contract within the system without affecting how the brakes work. Once pressure is applied to the system, that weak spring allows the pintle to close, and then we are working against that calibrated spring pressure against the springs in the drum brake assembly to delay operation of the front brakes. The moment the pedal is released from the driver, then it goes back to its normal at-rest state, allowing fluid to gently pass through. This is where, in this combination valve assembly, this is where we have a little piston that gets depressed if we need to pressure bleed the system. When we're pressure bleeding the system, we're applying pressure to the system, and that pressure will close our metering valve. If the metering valve is closed and we're only supplying a little bit of pressure to the system to flush it or service it, that's not going to be passing through the metering valve. So in order to bypass that, we have to depress the pintle mechanically so we can allow fluid under pressure to bypass the metering valve and allow us to flush and service the fluid in the rest of the system. Most of the time you'll find the proportioning valve, the metering valve, and the pressure differential switch contained within one assembly. With all of them in one place, it's serviced as one part, not serviced individually, and you can combine all of them together in a combination valve. This valve assembly here is also an example of a combination valve. This one's machined out of aluminum, and its mounting bracket ties it into the mounting point or the mounting flange of the master cylinder to the brake booster. So this will have brake lines coming off of the master cylinder coming down to the inlet side of the combination valve, and then from the combination valve we have our circuits coming out the bottom. This also has the electronic connector here for the pressure differential switch. And on the back side is our pin to mechanically override the metering valve. Now, depending on how the vehicle is equipped from the factory, there may be an integration of electronics into the braking system. This is part of an ABS system. It is controlled with a module. So this electronic unit right here, and these separate, and these are your solenoid valve assemblies. As the module commands the operation of the electronic solenoids, these will move fluid through the system and can limit pressure to certain wheels or increase pressure to certain wheels. So this is another method of modulation without using something like a conventional proportioning valve. This can actually limit the amount of pressure going to a brake assembly by controlling the hydraulic valves inside of here electronically. A system with electronic modulation like this will often take inputs from the wheel speed sensors. The wheel speed sensors are being monitored by the module, and the module can detect when there is a difference in deceleration when the brakes are applied. If there is more deceleration at one wheel compared to another, this can modulate the pressure to that wheel or to that brake and allow it to continue to rotate more while the other brakes in the system are being modulated normally. Until there's a difference, this will remain inactive. Once there's a difference, then this will take over and help control the amount of pressure or limit the amount of hydraulic pressure going to that wheel or the wheels that are trying to decelerate more than another. This also contributes to balancing out our brake application and helping the vehicle stop safely. At this time, I'd like to take the opportunity to show you a few different vehicles from different years and see what we can find on a quick visual inspection. The 1978 Jeep CJ5 doesn't offer very much as far as instrument panel information and lighting and warning systems other than the gauges themselves, and most of those gauges are mechanical gauges. With the key in the on position, there are no warnings or indicators except for our fuel injection check engine light. The brake lines from our master cylinder go down to the firewall and are protected by that coiled shrouding. And this goes down to the combination valve assembly located on the frame rail. And then the lines route to the different brake components. Here's the flexible hose, stainless steel braided hose coming from the front brake caliper. And the front caliper brake hose connects to a bracket, and then it joins the rigid tubing for the rest of the brake system. A 1978 Datsun pickup is not quite as primitive as a 1978 Jeep. However, it doesn't boast a lot of extra stuff either. We have some warning lights and a notice to fasten our seatbelts. We have no oil pressure, we're not charging, and our brake system is illuminated as well. In the engine compartment, we can quickly identify our master cylinder. And take note, one of those master cylinder reservoirs is larger than the other. Which one do you think is for the disc brakes, and which one is for the drum brakes? Larger capacity for disc, smaller capacity for drum. And our brake lines follow along the firewall down to the frame rail, where they branch out from there. As I was talking about earlier, this is the Nissan load sensing valve, or abbreviated the NLSV, located on the frame rail underneath the cab. 2005 GMC Sierra. A few more warning lights. The brake light included. Seatbelt, charge light, check engine light. And some other lights that timed out after the bulb check. Here's our master cylinder on the driver's side of the firewall. We can see our lines coming out of it. And right here is an electrical connector. Any guesses what that's for? If you guess fluid level, you're right. And here is a 2014 Honda CR-V. Several bulbs on the bulb check. Here's our brake warning light. Let's take the parking brake off. Turns off the light. No other issues with the system at this time. Newer vehicles offer less space to work inside the engine compartment due to increase in passenger compartment size. This is a good example of that. Another one you'll see this popular on are minivans and trucks, where the cab and the windshield overextend into the engine compartment. So here we can see our master cylinder reservoir for our brake fluid. In order to access the fluid, we have to pull back the weather stripping, pull off the cover, and then we can service the fluid. The master cylinder, however, is tucked way back in there. And our reservoir extends out farther forward so we have access point to service the fluid. Now if we follow the lines, they come around the firewall to the hydraulic control unit, or the HCU. This is a 1996 Honda Civic. Again, the brake light is on. If we put the parking brake down, light goes out. There's a contact in the parking brake to illuminate the light when it's engaged. Here's our master cylinder and reservoir assembly for this vehicle. We have a couple wires coming off of it. These are connected to the mechanical plunger style float assembly that detects level inside the reservoir. As the level gets too low, this will rest on the bottom, closing the contacts and illuminating the red brake warning light. If we follow our lines, they go to this valve assembly right here. This is our combination valve. And if you recall from the brake bleeding sequence, this is a front-wheel drive vehicle, front disc, rear drum setup, and its system is split diagonally.